I should be streaming now. Finally. Darn it. All right. Thank you all for joining me again. How to start a new stream. Apparently, every time you pause it, it doesn't let you pause the stream. It just ends it, which really sucks. Let's look at the GFS. I've not really checked the Kohara method, but yeah, GFS showing a lot of snow. First of all, you're going to get this a little event here, and then blasted with, wow, just... Let's look at the Kohara temperatures. This is the important part if you want a good amount of snowfall. Pretty supportive of snow. Let's look at 850 temps. Not doing so well with 850 temps. GFS is having a hard time handling that. Let's look at the Kohara method. Boom. Like, wow, just wow. Let's look at pivotal weather. Let's look at pivotal weather. Let's look at the Canadian model, GDPS, the Canadian. Temperatures in the 20s. Let's look at hour 108. Let's look at precipitation type and rate. Let's look at hour 120. Okay, 126, 132. Alrighty. This is what I'm... Wait a second. Which model? Oh, right. Of course, I was looking at the wrong time. Oh, Lord. Here we go. Really heavy snow. And let's look for 12 hours later. Just about ending. Okay. So this is important. This is really important, guys. This is when... So you're going to have at least hour 120. This is going to be a very quick storm, by the way. Very, very quick. It's going to be in and out very quickly. So you're not going to have like a 36-hour storm. The storm is going to last literally. So this is hour 114. The thing is, this is not when it begins. This is when it ends. So this is when this is where the precipitation is going to be at hour 114. This is where the cutoff is going to be. But of course, it's also going to be 6-hour increments. So 6 hours later, boom. So you're probably going to have snow beginning around hour, I would say. This is probably 2 hours of snow. Probably going to have, New York City will probably be around 1 hour, 118. 6 hours later, boom, you're having the heaviest snow. This is when you're getting the heaviest snow. That's why I think for this model, so snow should be ending just around hour, I would say this is where this low is going to be at hour 132. Okay, let's look at the Canadian, right? The GEFS. Oh, great, it's also in 6-hour increments. Wait, that's the... Okay, let's look at the Canadian. Let's look at precipitation type. This is also 3-hour increments. So it's going to be ending right around hour 132. What doesn't make any sense is you're having a storm system centered right about here. So you're having a very quick storm. Hour 117 is just when about the snow starts. Right around hour 117. Let's look at floater 1, floater 2. Nope. Okay. So hour 117 is just when it starts. So maybe hour 115, 116 is when it just starts. So hour 114, nothing. So right between 14 and 17. So probably 1 hour 116. So you're having, it's depicting a very fast-moving system. Usually when you're having such a deepening system with such a strong high pressure, it doesn't usually move this quickly unless you're having a very fast jet stream. Look at this. Yep. Look at that, very fast jet stream. So this storm is going to be out of here pretty quickly. So you're having a very fast moving jet stream. This is typical of La Niñas. With blocking, usually blocking pattern supports faster movement. Slower movement, but the blocking, by the way, is not very strong. If you look at the NAO, the North Atlantic Oscillation, it's not even going to be below a -1. You're going to have basically near neutral conditions, and around the time of the storm, you're going to have a negative NAO, but very briefly. In fact, this is the first time we are actually negative in winter in a couple years. This is why we've had little to no snow. So let's look at the NAO. Let's look at other teleconnections. Let's look at the Arctic Oscillation. Very negative. This is what you want to see if you want major snowstorms. This is very conducive for snowstorms. Negative Arctic oscillations. This is exactly what you want for major Arctic outbreaks and polar vortexes coming down. Look at this, guys. Look at this. You're going to have a lot of cold air in this country because of these negative AOs. These negative Arctic oscillations events really do support Arctic outbreaks into the U.S. I'm not going to stay around for the Euro model because I'm going to bed at 1. And that's about when the Euro comes in. So let's look at this. So you're going to have storm after storm after storm coming in. And usually the Euro comes in between 1 and 1:30, but I'm trying to be in bed by 1. So, all right, let's look at this right now. So snow. So a couple inches of snow. Let's look at the NAM. The NAM is also forecasting something similar. Wow, impressive, by the way. Let's look at precipitation type. This looks pretty likely. What the NAM is showing is pretty likely. So NAM is showing about, I would say 2 to 4 inches of snow, give or take, maybe an inch. Why am I saying 2 to 4 inches? Because this is not the high-res model, and I think like 3 to 5 is a good bet. Maybe 2 to 4, especially along the coast. Let's look at temperatures. That's a very important factor. You're going to have surface temperatures in the mid-30s. You're not going to have sub-freezing temperatures. You might get it if you get heavy enough snow. You might get some evaporational cooling and some dynamic cooling. Dynamic cooling is usually because of rising air. It's because you're going to have heavier precip. You have rising air, which will cool down the air a little bit, and also evaporational cooling. That's why it's called dynamic cooling. Dynamic cooling is because of evaporation, because of evaporation and condensation. When you have rising air and condenses, temperature cools. So that's basically dynamic cooling. So you're going to have temperatures in the low 30s. New York City, about 33 degrees. So it's going to be a heavy, wet snow. However, the storm for Wednesday is not going to be heavy, wet snow. It's going to be a dry snow. You're going to have basically, it's not going to be super dry like powder because it's not going to be that cold out. But the system can make its own cold air. I remember during the blizzard of 2010, December 2010, temperatures actually got below 20 degrees, though they were not forecasted to. The high temperature was forecasted to be around 30, low was forecasted to be around 24, 25. However, the storm got so strong that the temperatures actually ended up going below 20 degrees, and we got a very dry snow. It was like powder, basically, and it was blowing and drifting. Of course, this is a completely different system. This storm came out of the southeast, came out of the Gulf. It had a lot of Gulf moisture, was very tightly wound up. You had 50, 60 mile an hour winds. We're having damaging winds. There was even thunder and lightning. This storm, it looks to be more like the event that caused the 2016 storm, the Winter Storm Janice. Winter Storm Janice was a powerful storm. It produced a lot of snow, and it had a good amount of wind energy, but it was not as convective as the 2010 storm. you didn't have band after band after band just like coming in from, and you didn't have a lot of thunder snow. Because you had a storm with this case coming out of the, like, off the Carolinas and going up the coast, and you had very heavy precip. I mean, 6 hours you were having reds over New York City. I mean, you could double what you're seeing here, 0.3 to 0.5, so it's going to be close. It's going to be pretty heavy. Don't get me wrong, it's going to be heavy, but it's not going to be like what we had from those other storms, because these storms are going to be in and out really quick. I mean, look at this. I mean, just check this out. A very fast moving storm. I mean, if this storm can linger around a little bit, and then we could have a major storm. I mean, anything could still happen. Like, the storm could still end up being slower than forecasted, but the thing is, nearly all of the models are agreeing that this storm, while it's going to be very strong, it's going to be a very fast mover. Let's look at this. I mean, look how fast it's moving. Just boom. I mean, oh, sorry, that's that storm. So the movement is very fast. I mean, look at this. You're having a very fast motion right here. And then you're going to have another system. And let's see, when is that other system going to be coming through? Okay, let's look at SLP precipitation. Another storm, and then possibly of another system. Okay, so you're gonna have 2 major storms back to back. Are you kidding me right now? Cancel. Okay. Let's see. Let's look at pivotal weather. The Euro should just be coming in. Hold on for just a second. I'm just going to mute myself. All right. Rain, can I ask you something? I muted myself.
I don't want to talk right now.
Is everything all right?
Go back to your live stream. I don't want to talk it.
Oh, all right. Well, if any... All right. Love you. I'll be back in a few minutes. All right. Let me unmute that. All right. Okay. The Arctic oscillation, from what I checked, is negative, which means a disruption polar vortex. And you could see how the polar vortex is not staying in one location, and it's not like very strong. It's moving all about. I mean, it's breaking up, and then this is indicative of a strong polar vortex, but you're still having pieces of it ripping off. Usually, cold air over Alaska does not support very strong polar vortexes. This could end up being a Kona low, possibly. And these Kona lows typically lower snow elevation significantly for Hawaii. Oh, great. Let me just stop. Great. Hold on. Let me pause streaming for just a second because I don't want to. Okay, good. Okay, I'm streaming again. Good. Right, let me just upload this and send the link out. Where's my weather page? I mean going to send this to my weather group. Oh, there's this really cool YouTube channel I want you guys to be watching. It's called Mark Felton Productions. He's really cool. He makes historical videos, especially World War II videos. Really cool. And his theme song is pretty cool as well. Of course, he didn't ask me to do this. I've never met the guy. I'm just saying that I think his channel is pretty cool. So let's look at total precipitation accumulation. So there is a potential for a few inches of snow from this system. Let's look at SREF plumes. That's short range ensemble forecasts. Let's look at snow potential at least an inch. Okay, looks pretty likely. Well, showing it's going to be more of an inland event. So there's a potential for that too. The models have been trending further north. So let's look at pivotal weather. See if the European has come in yet. All right, so this is the UK map. This is okay. I don't really like this model. It's not very accurate. You're having a storm right now coming in. Let's look at total QPF. There's that storm that's coming in. So let's look at hour 126. Boom, major storm. Okay. Let's look at total. Okay, let's look at 6-hour QPF. 126. This is when the peak of it is going to be. This is when you're going to have very heavy snowfall rates. This is very heavy snow. Very heavy rain possibly. Hour 132. More heavy snow. Hour 138 is when it's just going to be leaving. So you're going to have an 18-hour snow event according to the UK map. So this is 24 hours, right? This is 12 hours, 1824. So you're going to have, this one is saying it's going to be a 24-hour event, or near 24 hours. So this is 12, 18 hours, so an 18-hour event. Let's look at total QPF, almost 2 inches. Let's look at surface temperatures. Is it going to be rain? Is it going to be snow? So this is a 32-degree line. So basically, when the peak of the precip is going to be coming in, marginal. So it's going to be right on the cusp. Let's look here. 35 degrees, 36. So 30 is off the coast. So it's going to be snow. No doubt about that. It's definitely going to be snow, and it's going to be a heavy snow at that. Let's look at 6-hour QPF. So very heavy snow. This could be rain as well. This could be having thunder snow possibly. Let's look at 2 meter. Let's look at 2 meter above ground temperature, so 32 degrees. Let's look at this. This is what I want to look at. 925 millibar temperature, height, wind. You're going to have a low pressure system here. So negative 4 degrees Celsius, you're definitely going to be having snow. Let's look at 700 millibar temps. Temperatures. Cold. So you're going to be having snow. You're definitely going to be having snow. 850 millibar temps. See? Generating its own cold air. Very heavy snow. I mean, this is the potential for at least a mega dump of snow. And I'm glad that it's coming right to me so I don't have to be traveling anywhere, especially since I'm running out of money. It's finally Mother Nature is saying, you know what? You missed out on enough snow for the last, 3 years? So I'm finally going to give you a little visit. I'm really happy about this. Let's look at the heights. 138. Pressure should be around 990 millibars. Let's look at the heights. Okay, yeah. I want to see what the surface is going to be. Surface and precipitation. Pressure. 2 meter wind barbs. So yeah. There we go. About 1,000 millibars. That's very low, actually. I mean, not low. That's probably will be somewhere in the 990s. We're having heavy snow here. Well, let's see how well these models do. Because UKMA is already showing a major storm. Let's see what the Canadian is showing. Because UKMet. Let's look at total QPF. About 2.5 inches. Wow. So Stony Brook is going to get dumped on. Maybe I should just stay here then. Or maybe I should go to the city. I don't know. because if I go to the city, it may, seeing all the cars being dumped with snow, that might be better. I don't know. Stay here and go there, or because Long Island usually gets rain, so I may just go back home, my apartment. Meter a ground, AGL means above ground lake surface. That's 2 meter temps, AGL. That's, of course, this is when you want to be looking at. This is when the heaviest snow is going to be coming down between 132 and 136. The temperatures in central Long Island, by the way, so 126, so 33 degrees. So it's probably going to be a little colder, honestly. You're going to have a lot of cold air. The storm is going to produce its own cold air, so it's probably going to be in the 20s. Let's look at the Canadian. Let's look at GDPS, which is the Canadian. Okay, this sounds a little more likely. You're probably going to have temperatures in the 20s. This sounds a lot more likely. I mean, look at these. Coastal New Jersey at 46 degrees. You just go a few miles west. Look how sharp this temperature contrast is. That is really, really sharp. That's really... Okay, and you're not going to be having snow here. You're going to be having all rain here. So, yeah, not a good depiction, honestly. 132, 138, still snowing. Okay, let's look at total QPF, 6-hour QPF. Wow, that is just off the charts. Yeah, that's crazy. If this is just a little bit further south, yeah, New York City is going to get dumped on. I mean, yeah, Long Island doesn't look like it's going to get that much. Yep. Long Island, if this verifies, Long Island will probably be getting maybe a foot maximum. But this area, through Lancaster, wow, Lancaster, my friend lives, Sean, he's going to get dumped on. I mean, in areas just to the west, even parts of Brooklyn, very heavy snow. This is the snowfall rates of at least 1 inch an hour. This is QPF. So this is, let's look at in terms of inches, right? So you're gonna have 1.3 inches per hour, right? And in an hour, right? In 6 hours, which is pretty heavy. That's 1.3 inches, 1.3 in 6 hours. So right, divide that by 6. And let's assume a snowfall water ratio of 10 inches for 1 inch of liquid. Standard snowfall water ratio. Let's not assume the temperatures. Let's assume normal snowfall water ratio of 10 to 1. So 1.3 divided by 6 times 10. You're looking at snowfall rates of at least 2 inches an hour. But now let's factor in temperatures. Let's say the snowfall rate, because of temperatures being, let's look at upper air, 700 millibar temperatures. Let's look at the Kohara. It's going to be pretty cold. You're going to have definitely conducive temps. Let's assume it's going to be at these temps. -9, right? So it's going to be very cold aloft. So snowfall water ratio, -9. That is going to be -9 times 1.8 plus 32. You can have a temperature of about 15 degrees. Let's assume it's 15 degrees Fahrenheit. Water ratio by temp. Let's see if the temperature is 15 degrees. Let's say it's not going to be 30. Let's say it's going to be 20 to 1. You're going to have a 20 to 1 snowfall ratio, right? 1.3 divided by 6, 6 hours, times 20. Boom, 4 inches an hour. A little extreme if you ask me. So let's say assume a 15 to 1 snowfall water ratio, which is probably more likely. Let's see. 1.2. Let's say it's 1.2. Say that model is being a little overdone, right? It's definitely probably being overdone. Divide that by 20, or by 6, times 15. Trying to be a little more realistic. So 3 inches. So you're going to have snowfall rates of 1 to 3 inches an hour, which is much more realistic. And of course, you're not going to be having these crazy snowfall water ratios. Ow! Oh, great. Okay, my chest is about to... Oh, God. I'm having an issue with my sternum right now. Hold on. Oh, okay, that's better. Yeah, I have a medical condition called costochondritis, which I'm actually going to be getting therapy for. Just popped. You probably didn't hear it, but my chest just popped. Oh, and I'm going to be getting off in about 3 minutes. Okay, close. Let's see. Wow, we have 4 people viewing this. All right, let's look at how much snow I think is going to come down. Most likely, you're going to be having at least 5 inches of snow. Definitely going to be having at least 5 inches. We're already up to hour 30, 36 now. So guys, let me just... I'm going to leave the live stream running. I got 2 minutes left because I'm going to bed. I want to load the rest of the European, but look, I have work tomorrow in the morning. I will actually resume this in the morning. I will definitely resume the stream in the morning. I'm actually going to be ending now because I have to shave and get to bed, so I'm ending it 2 minutes early, guys. I'm really sorry, but I have to go. Thank you all for watching, and good night. Before I go, here's what I'm expecting for New York City. This is my forecast. I'm expecting 12 to 18 inches for New York City, 2 to 3 feet for interior New Jersey, southern Connecticut. This is as of now. And I'm forecasting up to 2 feet for Lancaster. And when I say 12 to 18 for New York City, I'm talking about like Queens and Long Island. Manhattan might get up to 20 inches. Especially the further north you are, the more snow you're going to get. The thing is, closer to the coast, you're going to have not mixing, but you're going to have lower snowfall water ratios. But if you're going to get that heavy, really heavy bands coming in, and you're going to have some really heavy precip, then you're going to get more. So I'm still saying 12 to 18 inches because of the uncertainty of how these bands set up. So I'm just saying 12 to 18 inches locally higher.